All right, today we're going to talk about something that you probably remember from pre-algebra. That is slope-intercept form. All right, so you'll probably recall that the slope of a line, sorry, my little Apple pencil is a little skipping while I was writing. All right, no, the scribble erase. All right, anywho, slope of a line is the rise over run. All right, so this means that slope, which we denote with the letter M, is the rise over the run, right, being divided. Or you might see this symbol here is delta. We say it change. So the change in Y or the change in X. Or you might see it as y2 minus y1 over x2 minus x1. So always subtraction in there, right? y2 minus y1, that changes, like I said. So what that delta symbol means, the change in y's over the change in x. All right, a couple more things to know about slope-intercept form. The y-intercept, which is the y-coordinate of the point where a graph crosses the y-axis. All right, we often use a form of a linear function, which we're talking about today, called the slope-intercept form. Which, as its name implies, shows us the slope and the y-intercept. So this is what I'm always saying in math. We are creative. We name things. We tell it like it is, right? Like my two sons are son 1 and son 2. Not really, but you get it. All right. So we're going to go ahead and write some equations in slope-intercept form. So we're going to write the equation of a line with a slope -3 and a y-intercept of a half. All right, so I'm going to use the patch that I know that y is equal to mx plus b like so. And I'll just plug those values in. So y is equal to -3x plus a half. All right. Next, same thing. I can even just like duplicate that. Oh, no, not copy. Duplicate. Paste it down here. All right, y equals mx plus b. Same thing, right? Got our y-intercept of -2 and our slope of 0. Okay, so this one's going to turn out a little bit different than the last one. So when I plug in, sorry, it's bugging me how it's skipping a little bit there. All right, so when I plug in y is equal to, let me put 0 in for our slope, 0x minus 2. Well, what happens when I multiply x by 0? It's just going to become 0, right? So my equation will actually look like y equals -2. All right, now we're going to look at writing the slope from a graph. So we are, writing the equation from the graph in slope-intercept form. So the first thing we do, find the slope. Then we can find the y-intercept. So if I am looking for the slope, I'm going to find 2 points. Any 2 points will do. So let's say I notice the point right here. And we're looking for whole numbers. So where it crosses through whole numbers. So here to here. We want to look at how far, when reading the graph left to right, did we go up or down? So that's our rise. So it looks like it went 1, 2, 3. So in the numerator of my slope, I'll have -3. And then I went to the right, 1, 2, 3, 4. So I have 4 there. I like to kind of visualize the slope here. You could also think about it in terms of ordered pairs. So if, here, let's use purple and orange. My brother-in-law would be very happy with me. Okay, so let's think about these ordered pairs. This one is at 0, -1. This one is at -4, 2. And if we want to use the slope formula for that, we would take my purple point and put 2 over -4, and my orange point and put -1 over 0. So notice I took my y values and subtracted them. 2 minus -1, and my x values and subtracted them. -4 minus 0. And I kept the order the same, right? Which is why I kind of stack it 1 point at a time, because then it helps you keep track. Otherwise, you'll end up with the opposite sign on your slope than what's supposed to be there. All right, so what happens here is this becomes 2 plus 1, or I'll end up with 3 in the bottom, and 3 in the top, -4 in the bottom, which normally we do bring that negative either out front or up to the numerator, which is what we found looking graphically too. Pretty cool. All right, our y-intercept we did accidentally find here. It's that orange point that we were using, or -1. So that means if I want to write my equation, y equals mx plus b, then we are going to have y is equal to -3/4 x minus 1. There you go. Man, these are some colorful notes today. All right, 2 more examples. We can do this. All right. We are going to write the equation of the line graph below in slope-intercept form. Okay, so what we want to do, same thing, look for the slope. So I'm going to stick with looking at it graphically since we have the graph there instead of using the slope formula. So finding any 2 points on here. I don't know, this point and this point kind of stick out to me. And I noticed that I went down 1 and over 2 to get there. So down 1, right 2. So it's going to be a slope of -1/2. All right, and then my y-intercept crossing the y-axis, the y-axis right here. Let's think of 2. So my equation will look like y is equal to negative a half x minus 2. All right, last but not least, we are going to graph these two equations here on this coordinate plane. So the first thing that we're going to do is start by plotting the y-intercept. And what this is going to do is I call it the anchor. It anchors our line because there's an infinite number of lines that have the same slope as yours. So for this first graph, this is going to be negative 8. It's my y-intercept. Then we're going to use the slope to plot more points. Then I want to leave you a little note here. So the more points that you're able to plot, the more precise your line is going to get. So if my slope is 1/2, that means that I am going up 1 and then over 2, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, like so. Then I can connect the dots. That is our first one. And then let's look at the second one. So this one has this y-intercept of 4, the slope of negative 3. So it's going to go down 3 over 1. So then I'll connect those dots as well. Oh no! I broke up my line in a million pieces. That wasn't good. Let's try that again. Better. Okay. Those are our two lines. All right, we said it. Slope-intercept form.